Today we'll be learning how to calculate the steel of a beam section. As an illustration, we'll consider the figure as is shown in front of you. People, we have the beam section having a center to center distance of, the beam section is running up to 3830 millimeters. The wall width is 300 millimeters. Then we have the main reinforcement detailing. In this beam we have the U-shaped bars from the bottom of the beam, and we have the U-shaped bars again at the top of the beam. They are used as tie bars, and the bottom beams are used in order to restrict the tension stresses that are developed in the beam after it is being loaded. Then we have the extra bars, L-shaped extra bars at the extreme points of the extreme ends of the beam. Rather, we have the L-shaped bars from the two ends, and we have a straight extra bar at the middle span of the beam. The extra bars, the L-shaped extra bars at the ends of the beams, at the ends of the beam are there to restrict the hogging moment that can be developed when the beam is being loaded, and the extra bar that is placed along the midspan, that is here to restrict the sagging moment that will naturally be caused when the beam will be loaded. The detailing of the bars is such that we have the main reinforcement from the bottom side. We have the three bars of 16 mm diameter each running through the entire span of the beam. Then we have the tie bars that are 2 in number, and each having a diameter of 16 mm running through the entire span of the beam. Then we have the extra bars, L-shaped extra bars rather. We have them as we have two bars at each end of 16 mm diameter, and on the other end we again have two bars of 16 mm diameter running as extra bars. Then we have the extra bar in the mid span. They are 2 in number and each having a diameter of 12 mm. So the depth of the beam is more or less 450 mm, as we have the section of the beam as 230 into 450, where 230 will be its width in the section and 450 will be its depth. So we'll be calculating the total steel that will be used in such a beam, but here we will not calculate the stirrups. That will be taught in a separate part of this series. Here we are more or less concerned to calculate the steel, that is rather the main steel of the beam. So let's start. Now, as we are familiar with the sketch of the beam, we have the main reinforcement in the form of U, and having a diameter of 16 mm. We have 3 bars at the bottom and 2 bars at the top. The 2 bars at the top are just to hold the stirrups, and these are at times called as the tie bars. Then we have the L-shaped extra bars on two sides, and one extra bar is at the mid span of the beam. Now we'll be calculating the total cutting length of the bars for the main steel, for the main tension reinforcement rather. We'll be having the total length equal to 3830. It will be more or less it will be somewhat less than 3830, keeping in view the cover that is to be provided, but we take it equal to 3830 in order to cater the errors in the measurement of steel. To be on the safer side, we take it somewhat more than its actual length for the calculation, to be more precise and to avoid any sort of complications in the calculation. We take it equal to 3830 rather. Then we have to in actual it is somewhat less than 3830. So it will have a total length of 3830 plus the size of leg on one side and the size of leg on the other side. The size of leg on one side, keeping in view the cover that is to be provided, 25 mm on the top and 25 mm on the bottom, will be having the total depth of the cage rather, it will be equal to 400 mm, and that will be equal to the size of one leg. So the total cutting length of the tension reinforcement will be equal to 400 plus 3830 plus 400 plus the extension length at the bends. And at the bends, the extension length for a 90-degree bend is equal to 2 times its diameter. So we'll be having 2 times diameter on this side and 2 times the diameter on this very side. So the total cutting length will be such as is written over here. The cutting length of a U-shaped bar will be equal to 3830 plus 400 plus 400 plus 2 into diameter into 2. Since we have the bends at two sides, so we'll have one more 2 here, and this 2 is of the formula, and the 16 is of the 16 mm diameter. The total cutting length will be equal to 4694 millimeters, that is equal to 4.694 millimeters. Then the number of tension reinforcement bars that we are using in the beam are 3 in number, so we'll be having the total number of U-shaped bars will be equal to 3, and the total length will then be equal to 3 into 4694 millimeters, that is equal to 14.082 meters. Now the unit weight of a steel TMT bar is equal to diameter squared divided by 162. So we'll be having 16 squared, since we have the diameter of the bar equal to 16, and we'll be having 16 squared divided by 162, that will be equal to 1.580. This is the weight per meter run. So the total running meters we have here are 14.082 meters. Then hence the total weight of the bar that is to be used as the tension reinforcement will be equal to 1.580 into 14.08, that will be equal to 22.248 kilograms. Same will be the case in the inverted U-shaped bars, since the two are almost identical and almost equal in length. We'll be having the cutting length as 3830 plus 400 plus 400 plus 2 into 16 into 2, that will be equal to 4694 millimeters. Then you have the number of inverted, but here we need to keep in mind that the number does vary, so the total cutting length will duly get varied. Now the number of the inverted U-shaped bars is equal to 2. The total length will thus be equal to 2 into 4694 millimeters, that is however equal to 9.388 meters, and the unit weight per meter run will be equal to 1.580 as we have in the above case. Then the total weight will be equal to 14.83 kilograms only. Then we have the L-shaped bars. Since we have the L-shaped bars here, and we need to have some sort of attention for its length calculation, we have a total distance that is given in the figure, that is 950 mm, but it is simply given from the end of the support, and we know that the steel is embedded to half of the depth of the wall, so consider that thing also. We'll have 950 plus the half of the width of the wall, that is equal to 300 by 2, that is equal to 150 millimeters. Then we have the bend length, that will again be equal to 400 millimeters only. And then we have the extension at the bend. For a 90-degree bend, as we already mentioned, that the extension length will be equal to 2 times its diameter, and same stuff is used over here. For the cutting length, we'll be having 950, that is the distance that is given to us in the diagram as shown here. Then we have the 300 divided by 2, that is equal to the half of the width of the wall, and then you have 400, that is the bend length, and then you have 2 into 16, that is the leg length, and then you have 2 into 16, that is the bend length. So overall we'll be having a length of 1.532 meters of a single L extra bar, and we have a total of 2 extra bars at this end and 2 extra bars at this end as is shown here. So overall we have 4 extra bars that is used in this beam, and then we have the total length of L-shaped extra bar, that will be equal to 4 into 1 5.32, that is the number times the length of a single L-shaped bar. that will however be equal to 6.128 meters. Also, the unit weight of a 16 mm diameter bar is 1.580 as we computed earlier. Then we have total weight will be equal to 6.128 into 1.580. After that, we have the total weight of the four L-shaped bar, that will be equal to 9.6822 kilograms. Then we have the extra bar at the mid span. For its length calculation, we have to consider the center to center distance. We have the center to center distance at 3830. We'll subtract from it half of the wall width minus 450, and then half of the wall width on the other side minus 450 on this very side as well. As we have 450 on this side, we'll be having a symmetrical type of measurement on this side. It is not mentioned over here, but we'll consider it as 450 mm only. Then we have the total length will be equal to 3830 minus 150 minus 150 minus 450 minus 450 from this very side, and the total length will be reduced to the total length will be reduced to 2.630. Also, the unit weight in this very case will duly get varied because we have only 12 mm diameter bars. In the earlier cases we had 16 mm diameter bars, but here we have 12 mm diameter bar, so we'll be having a unit weight of 12 into 12 divided by 162, that is equal to 0.88. Now moving to the calculation, we'll be having the cutting length of 2.630. Then we have the number of extra bars, straight extra bars used in the beam, that are 2 in number, so we'll be having 2 number of straight extra bars. Then we have the total length will be equal to 2 into 2.680, that is equal to 5.36 meters. Now the unit weight of 12 mm diameter bar is 12 square divided by 162, that is equal to 0.88 kg per meter run. So the total weight for the straight extra bars that are used in the mid span and at the bottom side of the beam, that will be equal to 2 into 0.88 into 2.630, that will be however equal to 4.716 kilograms. Now the total steel will be equal to sum of these four cases, that is 22.248 plus 14.83 kilograms plus 9.682 kilograms and then 4.716 kilograms, and the total weight will be equal to 51.476 kilograms, and that will be equal to 0.51 quintals, that is obtained by dividing this very thing by 100, since we have 100 kgs in 1 quintal. So that's all for today. I hope you like the video. Please don't forget to subscribe my channel. Thank you.